The surface area of a hot air balloon A in square meters filled with hot air is given by the function A of r is equal to 4 pi r squared, where r is the radius of the balloon in meters. The radius of the balloon is increasing as a function of time t in second according to the formula r of t is equal to 2 over 3 times t cubed, given that t is greater than or equal to 0. So for the first part, we want to state the surface area of the balloon A as a function of time t. It's just like expressing A in terms of t. But since this is the chapter of function, we will be using function notation to represent this situation. So let me draw a diagram to help you to visualize the situation. Now I have three oval over here. Now the first one is the time, and the second one is radius, and the last one is area. So we use time to help us to get the radius. So which is this function? This function can help us to get the radius by using the time, right? So this is a function r. And once we have the radius, we can use this function to help us to get the area. So this is a function a. And the question asks us, to get to express to state the area of the balloon as a function of t. So it means that from here we want to directly go here. So we are actually looking for a composite function here. Now, what is the composite function that we are looking for? So you have to be careful. In this diagram, you know that r is the first function, a is the second function. Therefore, we need to write a of r of t. So this is a composite function that we are looking for. Still remember I told before, the function which is nearer to the variable here is actually the function which comes first. When you refer to this diagram, you know that r is a function which comes first and followed by the function r. Therefore, we need to write r is the first function and then followed by the function a. So therefore, we need to write a of r of t, not r of a of t. This is incorrect. Okay. Now, so let us focus on the first function first, which is r of t. So this one just copy from the quotients. This is 2 over 3 times t power 3. Okay, now the second part you need to be more careful. Now we are going for the second function, which is a. So 4 pi r squared. So inside the parentheses, if this is r, we write r over here. If this is 2, we write 2 over here. So for the next part, I'm going to replace the r by a parenthesis first. So 4 pi r squared. So what should I write here? It depends on what I see here. So now this inside the parenthesis is 2 over 3 times t power 3, right? So this is a new input for this function. So I should write this whole thing inside the parenthesis here. So this is 2 over 3 times t power 3. Okay, so now just square it. So here you will get 4, 2 square you get 4, 3 square you will get 9, and then here will become 6. Okay, so now just use your calculator to help you to do the expansion. 4 you will get 16. 16 over 9 pi t to the power of 6. Okay, so this is the function that we are looking for. 16 over 9 pi t power 6. Now let's go to the second part. We want to find the surface area of the balloon after 2 seconds. It means that when t is equal to 2. Now since we already got the function, that we can use the t to help us to get the area, right? So now we know that the surface area after 2 seconds when t is equal to 2, which is a of r of 2. Okay, just plug in 2 over here. So 16 over 9 times pi times 2 to the power of 6. Okay, just press your calculator. 16 over 9 times 2 to the power of 6. Okay, is equal to 1024 over 9 pi. This is square meters. Okay, this is the answer for part B. Okay, let's try one more question. Question number 4. A cylindrical container of radius 20 centimeters contains 200 cubic centimeters of water. The container is filled with water at a constant rate of 100 cubic centimeter per second. It means that every second, the volume of the water will increase 100 cubic centimeters. Okay, so for part A, write the formula of the amount of water in the container V after t second. So V of t is equal to, now the initial volume is 200, right? So I will going to write 200 first, plus then every single second the volume of the waters will increase by 100 cubic centimeter. So I'm going to write plus 100 times t. Okay, now it means that after 1 second it will top up 100 cubic centimeters. After 2 seconds, it will top up 200 cubic centimeters, and so on, right? Okay, so this is the answer for part 1. Now let's go to part 2. The height of the, we want to write a formula of the height of the waters in the container H in terms of V. So how do we get the volume of a cylindrical container? So the volume is equal to pi r squared height, right? Since the question asks us to express H in terms of V, so I'm going to change the subject. Now the subject is V. I'm going to change the subject become H. So I move the pi r squared over here. It means that H is equal to volume over pi r squared. Okay, this is pi r squared. Okay, so this is the answer for part 2. Now let's look at part 3. We want to find the composite function h of v of t. So h of v of t. So let's focus on the first function first, which is v of t. So we know that v of t is equal to this, 200 plus 100t. Okay, now this will become the volume. So I'm going to use this one to help us to proceed. Now V, I'm going to replace the V by this one, which is the volume, 200 plus 100t over pi r squared. But I know that the r is equal to 20 centimeter, right? So okay, this pi, the r, I'm going to replace the r by 20 because 20 centimeters is the radius. So don't forget to square it. Okay, so this is 200 plus 100t, and this is 400. 20 square, you will get 400 pi. So let me do some simplification. Let me do some factorization over here first. So just bring up 100. So this is 2 plus t. Now just simplify this one and this one, divided by 100 divided by 100. So here you will get 4. Okay, so our final answer will be 2 plus t over 4 pi. Okay, this is 4. Let me rewrite again. So this is 400. Divide this whole thing, you will get 4. Divided by 100, you will get 4. Okay, 4 pi. So this is the answer for part 3, composite function h of v of t. h of v of t, h of v of t is equal to 2 plus t over 4 pi. So this is the answer for part 3. Okay, now let's try part B. So we want to find the height of the waters in the container after 20 seconds. So we can use the composite function that we got just now to help us to get the answer here. So height of waters. in the container after 20 seconds is equal to h of v of 20 seconds. So now what we are going to do is copy everything here, just replace the t by 20. So 2 plus 20 over 4 pi. No pi, the question does not give us the value of pi. So normally in this situation, if no value of pi is given, the question will ask us to give our answer in pi. But when I refer to the answer given at the back of the textbook, the given answer is 1.75. So I think I will just use pi equal to 3.142. Okay, let's see whether this answer correct or not. Just press the calculator. So 2 plus 20 over 4 times 3.142. Okay, let me just round off it to 2 decimal places, so the answer is correct, which is 1.75 centimeter. Okay, this is the answer for part B.